Hi everyone. Today we're going to study histogram. A histogram consists of contiguous or adjoining boxes. It has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents. The vertical axis is labeled either frequency or relative frequency or percent frequency or probability. The histogram can give you the shape of the data, the center, and the spread of the grouped frequency distribution. Here are the steps to construct histogram. Step 1. Compute for lower and upper class boundaries of each class interval. The formula is given. For upper class boundary, that is equal to UL sub C. This UL means upper limit of the class interval, plus LL sub N. This is lower limit of the next class interval, all over 2. The upper class boundary of a particular class is equal to the lower class boundary of the next class. Step 2. Draw horizontal line and number it for class boundaries accordingly, and vertical line for frequencies. Step 3. Describe the classes by rectangles using lower and upper boundaries as widths and frequencies as height, respectively. Let us see one example. For 108 randomly selected college applicants, the following frequency distribution for entrance exam scores was obtained. Construct a histogram for the data. We have a table here with 2 columns. The first column is for class limits or class intervals. We have 1, 2, 3, 4, 5 groups. The first class interval is from 90 to 98. The second class interval is from 99 to 107. The third is from 108 to 116. The fourth class interval from 117 to 125. The last class interval is from 126 to 134. The second column is for frequency. There are 6 observations for the first class interval: 22, 43, 28, and 9 for the other class intervals, respectively. We need 2 more columns, and these are lower class boundary and upper class boundary, respectively. Let us now solve for this first blank here for the upper class boundary, which is for the first class interval. The formula is given to us, which is upper limit of the class plus the lower limit of the next class divided by 2. It means to say the upper limit is 98 plus the lower limit of the next class, which is 99. So we see here 98 plus 99, divided by 2, we have 197 over 2, that is equal to 98.5. We will copy this value on this blank, and there we go. Next, it was stated that the upper class boundary of a particular class is equal to the lower class boundary of the next class. So we have 98.5 for this blank, which is the lower class boundary of the next class. Going to our upper class boundary of the second class interval, we will use the same formula. So we have 107, the upper limit, plus 108, the lower limit of the next class, divided by 2. This is equal to 215 over 2 equals 107.5. And this value we will write here. Again, this 107.5 we will copy down here as the lower class boundary for the next class. Then, let us compute for this upper class boundary of the third class interval. So we have 116 plus 117 all over 2. This is equal to 233 over 2, which is equal now to 116.5. And this value we will copy here. And this 116.5 will be same as the lower class boundary of the next class. Then, let us compute for the upper class boundary of the fourth class. We have 125 plus 126 divided by 2. And that is equal to 251 over 2. And the quotient is 125.5. This value we will copy in here. Also, this 125.5 is the lower class boundary of the next class. And there we go. Then let us compute for the upper class boundary of the last class. We may use our same formula here. But did you notice a pattern here? Looking at the upper class boundary, it seems that the upper class boundary is equal to upper limit plus 0.5. Look at this 98.5. We can see that the upper limit is 98 and this is 98.5. It's like the 98 plus 0.5 will give the upper class boundary, which is 98.5. The same is for 107.5, that is 107 plus 0.5, we will get this value. And that is also true for this 116.5 and also for 125.5. It means to say, using that pattern, we can simply get the value for our last blank, the upper class boundary of the last class, and that is 134, this upper limit, plus 0.5, we will get 134.5 that we can write in here. Also, for the lower class boundary column, if we look at our lower limit, this is 99, it seems that this 98.5 is the result when we have lower limit minus 0.5. So you see, this is 99 minus 0.5 will give 98.5. Also, this 107.5 may come from 108 minus 0.5. This 116.5 comes when we have 117 minus 0.5. And the last, the 125.5, may come from 126 minus 0.5. On the same note, we can compute for this blank, for the value lower class boundary of the first class. We can get the lower limit 90 and then minus 0.5, and we will get this 89.5. We may copy now this value for our lower class boundary of the first class interval. Our table now is complete. Let us now write the histogram. First, let us draw the horizontal line and the vertical line here. In the horizontal line, we will write the class boundaries, and for the vertical line, we will write the frequency. Now let us describe the first class interval. Take note, the first class interval has lower class boundary of 89.5 and the upper class boundary is 98.5. So this is from this point up to this point in our horizontal line. So the rectangle corresponding to our first class interval is given here. The width is from 89.5 to 98.5 and the height is up to the level of 6 in the frequency. For the second class interval, we have the class boundaries from 98.5 to 107.5. So this is our interval, and the rectangle corresponding to that is this one with a height that is equal to 22 in the frequency. The third class interval has class boundaries from 107.5 to 116.5, and the rectangle for this class is given here with a height of 43 in the frequency. For the fourth class interval, we have class boundaries from 116.5 to 125.5, and the rectangle corresponding to this is given with a height that is equal to 28 in the frequency. For our last class interval, whose class boundaries are 125.5 and 134.5, the rectangle is given here with a height that is equal to 9 in our frequency. So this is our histogram now, and this is our final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study frequency polygon. Let us define frequency polygon. Frequency polygon is obtained by joining the points by straight line plotted for the frequencies for each midpoint of the class. Midpoints are plotted along the x-axis and the frequencies to y-axis. The two endpoints of the graph are connected to the horizontal axis to make it as a closed figure. Let us see this example. Construct a frequency polygon for the distribution. This is the distribution. We have two columns. The first column is for the class limits. There are 1, 2, 3, 4, 5 classes. This is the column for the frequency. A frequency of 3 for the class 90 to 98. A frequency of 5 for the class 99 to 107. A frequency of 10 for the class 108 to 116. A frequency of 13 for the class 117 to 125. A frequency of 4 for the class 126 to 134. For our solution, let us do step 1, and that is construct another column for midpoints. This is the column for the midpoints denoted by x sub m. We're going to use the formula lower limit plus upper limit divided by 2. We know that for this class, the lower limit is 90 and the upper limit is 98. So for us to find the value for the first blank, we will write x sub m equals 90 plus 98 divided by 2. The sum of the numerator is 188, and this is now divided by 2. The answer is 94. And this value we will write here. For the second blank, the value is 103. That is 99 plus 107 divided by 2 equals, the sum is 206. Divided by 2, we will get this 103. The third value here is 112. That is 108 plus 116 divided by 2. The sum of the numerator is 224, and this is divided by 2, so we get 112. The next number for the midpoint is 121. That is 117 plus 125 divided by 2. The sum of the numerator is 242. Divide by 2, the answer is 121. The last value is 130. We got this from 126 plus 134 divided by 2. The sum is 260 over 2, so we get this 130. We are now done with the column of the midpoints. For step 2, we're going to plot the points. The midpoint is the x-coordinate, while the frequency is the y-coordinate. So we can see here, this is the x-axis, where the midpoints are listed, and for the y-axis, the frequencies are here. The first point is the 94, 3. So we have this point. The second point is 103, 5. This is the point. The third point is 112, 10. Here is the point. Next point is 121, 13. Here is the point. The last point is 134. Here is the point. Next, let us connect these points with straight lines. Here now are the points connected by straight lines. Next, step 3 is to connect the two endpoints of the graph to the horizontal axis. It means we're going to add two more numbers of midpoints in the x-axis. One after 130 and the other one is before 94. Take note that the interval between midpoints is 9. So, the first number here would be 85 and the other number here is 139. It's like we're adding another midpoints but with zero frequency. Here are now the points, and we connect these points with the endpoints of the graph. This is now the frequency polygon. This is the final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study ogive. Let us define ogive. Ogive, or cumulative frequency graph, is a graph that relates class boundaries and cumulative frequencies of a distribution. Class boundaries values are scaled along x-axis and cumulative frequencies are scaled along y-axis. Here are the steps how to construct ogive. Number 1, plot the cumulative frequency for each upper class boundary. Step 2, connect all the plotted points by straight lines, starting from the lower class boundary of the first class. Let us see this example. Construct the ogive for the distribution below. Here we have two columns. The first column is for the class limits. We have 1, 2, 3, 4, 5 classes in here. The next column is for the frequency. A frequency of 3 for the first class, 90 to 98. A frequency of 10 for the class 99 to 107. a frequency of 15 for the class 108 to 116, a frequency of 7 for the class 117 to 125, a frequency of 5 for the class 126 to 134. The next is, we will make two more columns. The first column is for the cumulative frequency and the other column for class boundaries. Let us complete the column of cumulative frequency. The numbers are here. The first number 3, we copy this from the frequency of the first class. Then 3 plus 10 equals 13. We write here 13. 13 plus 15 equals 28. 28 plus 7 equals 35. 35 plus 5 equals 40. Next, let us complete the column of class boundaries. Here are the numbers for the class boundaries. All these numbers to the left are called lower class boundaries, while these numbers on the right are called upper class boundaries. Let us consider the first class boundaries corresponding to the first class. The lower class boundary is 89.5. We can get this value from the lower limit here, which is 90, that is minus 0.5. So we get here 89.5. The upper class boundary is 98.5. We can get this value with respect to the upper class limit, which is 98. Obviously, we added 0.5, so we get this 98.5. That idea is true in all the class boundaries respectively. Take note also for this upper class boundary 98.5 for the first class. This is equal to the lower class boundary of the next class. That is true in all the other classes. For step 1, let us now plot the points. Take note that the upper class boundary is used as the x coordinate, while the cumulative frequency is for the y coordinate. It means to say, when we write our x and y axis, the x-axis represents the upper class boundaries, while the y-axis represents the cumulative frequency. So we can see here in the x-axis, the values are written as 98.5, 107.5, 116.5, 125.5, and 134.5. Let us now start plotting the points. Let's begin with the first point, that is 98.5 and 3. This is now the first point. The second point is 107.5 and 13. This is the point. The third point is 116.5, 28. This is the point. Next is 125.5 and 35. Here is that point. The last point is 134.5, 40. Here is the point. Step 2, let us connect the points with straight lines. Here we go. The points are now connected with straight lines. For step 3, let us connect the first point to x-axis, adding the lower boundary of the first class. The first class is here. The lower boundary is 89.5. So we added the 89.5 here, and then assuming that this 89.5 has zero cumulative frequency, and that is the point. Connecting this point with the first point of the graph here, so here we go. This is now the ogive for the given distribution. This is our final answer. I hope you learned something from this video. See you again next time.